So the most important distribution we'll be playing with this semester is the normal distribution. Um, this is something that occurs often in nature, this idea that things are unimodal, symmetric, and follow a bell curve. So we can see the drawing of our normal curve right here. It's got that bell shape. We do know some stuff about this. In fact, when we saw the empirical rule back in, I don't know, part 2, remember, we could talk about the different sections under this normal curve, and within one standard deviation, we had about 68% of our data. Within 2 standard deviations, we were at 95% of our data, and when we went out to 3 standard deviations, we got 99.7% of our data. So we have these sort of rules still going on underneath the surface, but we're going to be able to get more exact and talk about more than just a particular, those particular 3 cut points. So in order to talk about a normal curve, we need 3 pieces of notation. So x is still going to be our random variable, just like it has been with the binomial and with our uniform distribution. And then we also have mu, the mean, and sigma, the standard deviation. Now, remember, we've seen mean and standard deviation before. In fact, in our calculator, we have x bar and s of our x as well. These are our statistics. These are values, our mean and our standard deviation from a sample. Since we're in part 5 and we're in like math land, we're now going to be dealing with these things, which are parameters or real true values, right? Because we're in this land where we're able to say like, oh yeah, we know this because we're in math land. So when we are talking about, math land, we're going to be using these Greek letters mu and sigma as opposed to x bar and s, which we used back in part 2 a little bit more. But we have seen mu and sigma before. We used them when we talked about z-scores and when we did a little bit of empirical rule stuff back in part 2. So if our random variable follows a normal, just like when we had binomial, as a reminder, when we had binomial, we could say x follows a binomial with n trials and p probability of success. That told us everything we needed to know about a binomial. We can do similar with our normal. Now we're going to say x follows an n for normal with that mean and standard deviation. And again, with the mean and standard deviation, we know everything there is to know about this variable. We know where it's centered, we know how spread out it is, and since it's normally distributed, we know that it is unimodal, symmetric, and bell-shaped. So the standard normal distribution, which we used when we did z-scores, is basically a normal distribution where we have done some transformation of our variable to have it centered at 0 with a standard deviation of 1. These are used all the time in tables, which we're going to see next. So basically, this brings us back to z-scores telling us how many standard deviations above or below the average you are. So 2 different ways to look at our stuff. I do like to ask questions about knowing the mean and the standard deviation for a z-score or for a standard normal are 0 and 1, because we're going to be using the standard normal distribution when we get to hypothesis testing and confidence intervals in part 6. So having a good understanding of what the heck those z-scores represent or those values represent is very important.